All right, we're back. We're on page 191, math analysis. We're talking about parametrics. We did parabolas. Now we're going to do circles. It's kind of a hurricane type situation going on outside my house. We've had 3 trees fall so far. One of them, fell kind of on the property line, didn't really hit anything. Another one took out our shed, but fortunately the shed was in the way of it taking out our house, so that was nice. And then another tree fell and hit our side porch. So I don't know. I might be cutting this short to go and, I don't know, save something or save myself. Who knows? But what better use of time while you're sitting here trapped in this situation? So, all right, let's see. So circles, I would say, are probably the second easiest, but we're going to do a lot with them because it turns out a lot of things move in circles. I mean, that's kind of the idea. So we know how to parameterize a circle because we know the unit circle. And we've seen that if we use sine squared of, let's say, t plus cosine squared of t equals 1, that's going to let us parameterize a circle. So in general, though, it's going to be a little more detailed. So it's going to look like, so I'm just going to tell you this outright. I don't know. My adrenaline's really pumping because this weird situation. I don't know if it's the best thing to do, but like I'm doing it anyway. So you're going to get your h plus r cosine or sine. It doesn't matter. It could be plus r, it could be minus r. We'll see as we go. This is just like a simple template to get us started. And then we're going to have to think more about it as we go. Like if this is what we have, then here's your hk, and then your circle. And then you're going to start here at t equals 0, and you're going to go this way. And it takes 2 pi for a revolution. So to go all the way around, it's going to take you 2 pi. So let's see if we can do something related to that with these. So we want, our center is going to be -3, 4, and we're going to pass through 12, 6. So what we don't know right away is we don't know the radius. So let's find the radius. So the radius is a distance formula. So 12 minus -3 is 15, and then 6 minus 4 is 2. So 2 radical 229, I think. Okay, and then the center is -3, 4. So we're going to go with. So let me just do this in non-parametric, right? Non-parametric, it's going to look like x plus 3 squared plus y minus 4 squared equals 229. So we have this. Now I'm going to write the parametrics. And I think that when you look at it, you can kind of better appreciate the parametrics. If you've already seen the rectangular, I don't know, we'll find out. -3 and 4 plus radical 229. I'm going to go with cosine because if no one tells me what to do, I'm going with x is cosine, y is sine 100% of the time. Unit circle, it's always going to start on the rightmost point, and then go counterclockwise. So if no one tells you what to do that. 29 sine. All right, I'm going to switch over to GeoGebra and make this happen so we can see that we got it right, and also like kind of quickly play around with some other parameterizations. But this is done. This is the right thing. Got leaves flying all over the place. Let me tell you, we have evergreens like right next to our house on one side. They're not even moving. If you're going to live someplace where you're going to have hurricanes, evergreens are the way to go, right? So they look like Christmas trees, but they're giant. Then we have all the other whatever leafy trees all over the place. They are getting my heart pumping. I don't know. Not happy about this. All right, I'm gonna go with curve, and then it's gonna be -3 plus square root 229 and cosine of t, comma 4 plus square root 229 sine of t. So this is a good thing about GeoGebra, is like just play around, right? It should take 2 pi. And now we don't see anything, but that's because we literally can't see the circle because it's so big. Okay, now the fun. Let's put a point on it. I'm going to do a of v, and v will become a slider. And let's go 0 to 2 pi. 0 to 2 pi. Let's do 2 pi plus 0.1, right? So that it'll go all the way around. And then what I'm going to do, plus 0.1, let's do 0.01. Let's do 6.2. Let's do 6.29. And go by 0.01s. And then if we put this back at 0, and hit play, we'll see something going around a circle counterclockwise, starting at the rightmost point. Things are looking good. All right, what if we tried a different parameterization? Let's copy. So the 3 dots, duplicate. I'm going to switch sine and cosine. So I'm going to change this into sine. Oh my gosh. It's so hard to mess around with things because it like tries to guess. Sine of t. And then I'm going to change. So right now it's a line because if you eliminate the parameter on this, you'll just get a linear equation because of the sine of t and sine of t. Solve both of them for sine of t, set them equal. It's a line. Here, I'm going to change this to cosine. Okay, so what happens? X starts in the middle because it's sine, and it's going to increase. So you're going to start in the middle and kind of go to the right. And then the y value is cosine, so it starts at the top. So I'm thinking that this is going to start at the top and go clockwise. So let's put a point on there. Let's go back to 0. And we will see. So the top is, it should be above -3, right? Because -3,4 is the center. And we go, starting at the top, going clockwise. That was weird when they like switched. It looked like they just traded names for a second. And we get that. So that's doing what we want. Play around with it. Make some things positive, some things negative, like whatever you want to do. All right, let's go back to the notes and see what the next question is. And if we want to do it in this video. Because we might want to, I don't know, I might want to cut these short in the event that I have to like jump up and get out of here. So yeah, I'm going to cut this video here. I'll come back in the next one and do the next problem. You need your calculator, so if you don't have it with you, find it, and I will see you there.